Ensuring your UI looks good across multiple different aspect ratios and resolutions is an incredibly important part to making your game feel done and polished. With UGUI, we had an option to use a canvas scaler and it would handle a lot of this stuff for us. With the introduction of UI Toolkit, on the panel renderer or the UI document, this was a missing setting. However, we get all the same controls in the panel settings. In this video, we're going to take a look at each one of the potential options, how it works, some of the drawbacks, so you can make the right decision for which one you want to use for your game. Hey, Chris here from LlamAcademy, here to help you. Ooh, me? Yes, you! Make your game dev dream become reality by helping you make a more polished feeling UI. Those of you looking for the short, how do I just do this thing answer, if you've already used UGUI and you're familiar with the canvas scaler, you can go into those panel settings and find the exact same controls that'll work exactly the same as you expect. Make sure you like and subscribe before you close the video. And in fact, in this video, we're going to use the UGUI canvas scaler to inspect more closely exactly what's going on under the hood, because with UI Toolkit, we don't have game objects, so it's a little bit harder to just tell what's happening. So getting something a little bit more familiar, such as seeing the scale change, is a lot more relatable. If you haven't worked with the Unity UGUI or the old system that was introduced back in 4.6, don't worry, we're going through all of the possible configurations and taking a look at when we should use each one in this video. It is important to note that starting with Unity 6.5, they have deprecated the UI document and we're now using a panel renderer. You just swap the two out and you're good to go. Let's dive in. Over here in Unity, I'm using the 6.6 beta, but 6.5 plus all should look exactly the same. And again, the panel render settings have been here for a long time. To make a UI with UI Toolkit, you just go to right click, UI Toolkit, panel renderer. And on earlier versions, as I said, you'd use UI document. That'll give you a panel render with some panel settings automatically attached, and you should have no source asset by default. It also creates this UI Toolkit folder with those panel settings and a Unity theme. The panel settings is where all the magic happens because we have these scale mode and scale mode parameters inside the panel settings, and that's exactly how we configure how the UI scales. There are a couple different options, and I like to start with the documentation anytime I'm doing something new, because Unity's documentation is usually pretty good. So in scale mode parameters, we see we're starting here on constant pixel size. That's exactly what we saw. And it says sets elements to stay the same size in pixels regardless of screen size. What this effectively means is if you use this mode, you are the one that should be manipulating the scale. It's going to keep everything looking the exact same as it's authored in UI Builder or your UXML and your USS. For example, in our demo UI, let's open that up in UI Builder. We just have a couple of items here, top left, bottom right, bottom left, that are anchored to those positions. We've got this little resources container up here that's anchored to the top right. We've got this big pop-up text that is anchored again, 100 pixels from the top, and a button in the middle. We've got the bottom bar container, which is designated as 300 pixels tall. This middle button is also listed as 400 by 100. Importantly as well, this view is 1920 by 1080. That's my personal preference in designing a UI, is I will use 1920 by 1080 because that's what something like 75% of gamers are playing on, and worry about the scaling from there. So I'll design it here, and this is my reference resolution. So in the game view at 1920 by 1080, we're going to see exactly the same, regardless of what we set over here on our panel settings scale mode. Constant pixel size looks fine. However, if we start scaling down to like 1366 by 768, everything gets really big. That's because all these elements, like these buttons, are still taking up exactly 400 pixels. The text is 72 pixels tall. These buttons are all 400 by 100, and this bottom thing is 300 by the full width. So we would need to lower the scale to match, I think 80 is the right amount, but to match what our resolution is. So you would, in your code, need to come up with some mechanism to scale the UI based on your reference resolution and the target resolution. That kind of sucks, and that is why the option scale with screen size exists, because it's going to automatically do this for us. When we go to scale with screen size, it adds many different configurations here. Screen match mode, match width or height. We can also choose shrink or expand. It asks for reference resolution, and since we designed it 1920 by 1080, that's what we're going to put here. And then we have different options to should we match the width or the height. Notice as we move this between 0 and 1, nothing changes. That's because the aspect ratio is the exact same. 1366 by 768 is the same 16 by 9 aspect ratio as 1920 by 1080. So if we match width or height, it doesn't really matter. It's going to be the exact same. If you pick a value somewhere in the middle, it will, if we go like exactly 0.5, it'll try to put half of the width and half of the height. So it'll scale it proportionally between the two. And you can choose any value in between. If we choose something like 800 by 600, the OG resolution, with the screen match mode parameters match width, it looks like this. It's a little bit hard to tell what's going on. So if we come back to our documentation, scale with screen size, match width or height, scale the canvas area with the width or the height as reference, or linear interpolation between the width and the height. That somewhat makes sense. And if we move between the two, we can see that it has different effects, but it's a little bit hard to understand how it's achieving that. So I like to use the UGUI version of this to explain this a little bit better. If we just disable a panel render and enable the canvas and change our canvas scaler to scale with screen size, reference resolution of 1920 by 1080, match width or height, check out the scale over here. Let's move it over here. Our scale is 0.41667 all the way across, but the width is staying 1920. So we are matching width 100%. So we're saying this canvas is 1920 wide, but we have to scale it down to fit on an 800 by 600 screen to 0.41667. As we scale it over to height, we'll see that height now remains at 1080, and we have to scale it down to 0.55556 to make sure that it fits on this 800 by 600 screen. And then you can see as we go in the middle, it has linearly interpolated the width down to 1662 and the height to 1247 and adjusted the scale so it fits on the screen. Conceptually, the panel render is doing the exact same thing. In fact, if we disable the canvas and re-enable the panel render, come back to panel settings, you'll see that it looks the exact same as what we just saw as we do that. It's just we don't have the underlying game objects. We just have the panel render. So we don't see all of this stuff that's happening. Our panel render still stays at scale 1. When we start doing weird stuff like 1610, we get a little bit different behavior based on which one we're going to match. For very close aspect ratios, matching width works pretty well. If you go to a wildly different aspect ratio, like a vertical aspect ratio, the width one doesn't work anymore. And height also doesn't really work. See, we have stuff going off screen. Stuff starts getting really close to each other. But most likely in your game, you're not going to support this type of resolution. You'll probably work mostly on a 16 by 9, 16 by 10, maybe even a 32 by 10, maybe the extent of what you really go to for an ultra wide. And for this type of monitor, matching width does not work well because, again, let's go back to our canvas. In this case, we have kept the width at 1920, but our screen size is double that. So we've had to zoom in 2x to make it fill the whole screen, and our height was actually cut in half. So this UI becomes not really usable if we're matching the width. With height, it works pretty well. Everything gets pushed out, which is pretty typical if you anchor stuff to corners and you go to an ultra wide, everything gets very spaced out. But this looks much better than the alternative here of width. And of course, you could try something in the middle to bridge the gap. None of these scale modes is necessarily right or wrong. That's why they're all available. You can choose the one that you feel works best for your game and that clicks best in your brain. The next option is shrink, which will crop the canvas area either horizontally or vertically to the size. So the size of the canvas is smaller than the reference. What that means is that our canvas size, our 1920 by 1080, is the maximum size that will work. Again, let's take a look at our canvas. If we come down to shrink, notice here our width is 1920 and our height is 540. That is the same as when we had match width or height as width, but we are no longer specifying should we match width or height without that extra parameter. So we come to like 8x6. Now we have matched height. So it's a dynamic matching of width or height, which I feel like in most cases works pretty well. We do have outliers like our ultra wide where it does look not good. On a 16:10 aspect ratio, still looks pretty good. And on a vertical one, still, these are always going to not look good. So our shrink will guarantee that our canvas will never exceed what we have specified as our reference resolution. Notice here we have 1080 height. On 8x6, we again have 1080 height. And the ultra wide, we only have 1920 wide. For UGUI development, this was actually my favorite mode. It worked the best for me. I'll talk a little bit more about why I don't prefer this one in UI Toolkit at the end of the video. If we use shrink mode, we'll see we get the exact same behaviors, 9x16, and of course this as well. With expand, it works the inverse. It's going to expand the canvas area either horizontally or vertically, so the size of the canvas is larger than reference, meaning it will never be smaller than what you have specified, the 1920x1080. This tends to be my favorite match mode in UI Toolkit. If we take, let's use the weird resolutions like 800x600, it still looks pretty good. And if we go to the ultra wide, that's this one, it looks good. If we go to a small one, it looks good. This one always looks good with UI Toolkit and doesn't have some of the problems that we're going to talk about in a little bit with shrink. It tends to handle our ultra wides. It doesn't work, like none of them really work on a vertical resolution. It at least doesn't crop everything out. It expands it out, but it becomes very small and difficult to use. Conceptually, let's look at UGUI again. If we go to expand, here we go. We'll see that the width is 1920. So that's the minimum size because we said we will never go smaller than this. And it just blows up the height to fill the available area and then has to zoom out. That's why everything looks so small. On an 8x6, we're still keeping 1920, but now our height is 1440. So we've blown up the height and had to zoom out so it looks okay at this 4:3 aspect ratio. And again, on the ultra wide, the height will never be smaller than what we've specified. So it's going to be 1080, but we're going to blow out the width to 3840, which is what we have here. And we keep the scale at 1. There's only one other option we have on our scale mode, and that is constant physical size. With constant physical size, the goal of this is that elements stay the same physical size regardless of the screen size and resolution. So you set a reference DPI, which is the screen density that your UI was designed for. And when it renders it, it tries to find what is the DPI of the screen and compares it to the reference DPI, and then scales accordingly. And if for some reason it can't find the DPI, it will use the fallback DPI. The way this one works is very similar to constant pixel size, except it's going to try to keep all elements at the same physical size, regardless of the DPI changes to monitors. For example, if I have a 400x100 pixel button that on my screen, let's say takes up 2 square inches, on a 4K monitor, it would still try to take up 2 square inches. I don't particularly like this scaling mode because I find it's relatively challenging to test. There is a package called Device Simulator Devices that you can install from the package manager. Just search for device and you can find it right here, which allows you to come up here to the game window and click Simulator and pick some different devices. So if you want to play, I don't know, on a Motorola Moto E or whatever, it'll show you how this works, and it will even, you can even rotate it, all this kind of stuff, which then if we use our constant physical size, we'll see how it would look on this device. Now, obviously here, the reference DPI is too small, so we need to crank this up a little bit to try to make it look a little bit better. We're gonna go 500. Then you can play with all these different options, and it will ensure that all of your elements that show up on the screen will be the same physical size regardless of the device. This isn't going to be a tutorial on how to use a device simulator, but you can see that in this particular case, it wouldn't work that well because some stuff gets cut off because of these rounded edges. Those are all the scale modes that UI Toolkit has available, and I hope you now understand how each of them works so you can apply the one that works best for you in your brain to your own game. My personal favorite, as I said earlier, is expand for UI Toolkit. When I'm designing UIs in UGUI, a lot of times I have stuff off screen and have it animate in. And with UGUI, you're generally attaching monobehavior classes, or at least I am, to each of those off-screen elements. So I can't have them game object disabled because a lot of times they need to set up stuff on start or awake or something of that nature, and then do any data fetching when they come in. With that paradigm, using expand will show stuff that is off screen. So I don't like using expand in UGUI because it will tend to show stuff off screen in different aspect ratios or resolutions than what I designed for. And that ends up looking dumb when you can see some of the stuff off screen. With UI Toolkit, we're not attaching mono behaviors to stuff that's off screen. So if we are going to have a panel or a page or something of that nature that's off screen and it's going to animate in, we can say, hey, just don't show this thing. We can use display none. We can use opacity 0. We can use picking mode ignore. We can do all of those things to make sure that we can't see or interact with this element. So if we use expand and it's technically on screen, it's not as big of a deal. We also can style stuff to say, hey, be at the far right of the screen or be 100% off screen starting from the right. So if the panel has expanded, it's still okay. That thing will be pushed off screen. So the mechanisms we have, some of the tools we have, changed my preference on this. 4 years ago, I made basically this exact same video, but for UGUI. And I said, I prefer shrink. It just works the best. And for UGUI, I still do use shrink. I feel like it works the best for that particular scenario based on my usage of the tool. For my usage of UI Toolkit, I think expand works the best. I think expand typically works the best in terms of actually resizing stuff. We just had other issues that made shrink work better for UGUI. I hope you got a lot of value out of this video. And if you have, make sure you've liked and subscribed. And if you want to show your support for LlamAcademy, there's a few ways you can do that. Number one, I've got a brand new UI Toolkit course coming out with Game Dev TV. When that's out, I'll have that linked in the description below. That is an introduction to UI Toolkit. It's not an advanced course. It's more of a, I haven't used UI Toolkit before. Let me make sure I understand how to use all the tools I have available to me. So if you are new to UI Toolkit, definitely you want to check that out. We do step-by-step building out cool animations, a main menu, an inventory, all these important things that we need to understand when we're making UIs with UI Toolkit. Other ways you can show your support are you can do super thanks right here on YouTube for a one-time donation, or you can become a Patreon member or a YouTube supporter for recurring contributions. With both of those options, you'll get behind the scenes footage on some projects that I'm working on. You'll get access to a private members exclusive Discord. And starting at the awesome tier, you'll get a shout out at the end of every video, like these awesome folks: Jason Hansen, Iphiabolus, Snedden, Mustafa, Nick5454, and Pixel Wizards. There's also all of these great supporters as well. Thank you all for your support. I'm so incredibly grateful. And I'll see you on the next video.